Welcome everybody. Hi everybody, welcome. Thanks for coming today. My name is Adrian and today I'm going to talk a bit about server-side rendering in a serverless environment. Just a quick introduction. My name is Adrian and I am a full-stack developer at a company and a startup called Webiny. Just a few words about Webiny. Well, basically, we are a platform that empowers developers, to create serverless applications. So, in other words, we provide them with the tools and applications that they can use in their own work. And we built all that on top of these technologies. So we have Node.js, MongoDB, GraphQL, and for all of our front-end needs we use React. And currently, we mainly work with AWS, but we also have plans to explore other cloud providers like Google Cloud and Microsoft Azure. So the topic I am about to talk to you today, so server-side rendering in a serverless environment, is a pretty important topic for us because, as I mentioned, we also provide a few apps for our users. And one of the apps that we provide is the Page Builder app. And as the name itself says, it's an app that enables users to create pages. And at one point in time, these pages have to go live, right? So when that moment comes, these pages have to be served, as fast as possible, of course, and with great support for search engine optimization, or SEO. And in this talk, I'm going to, quickly describe what we have tried and which approaches we tried in a serverless environment. But before I continue with that, I just wanted to get a quick overview. If you can raise hands, how many of you have been working with serverless? Maybe, as a side project, just doing something for fun on a local machine, or maybe in production. Have you worked maybe with serverless? Okay, cool. Okay, so for those who may be less familiar with this concept, I'm just going to dedicate a few slides to this. If you go online and search this term, you will see that there are a few different definitions of this concept, and it's often misunderstood by the developers. So one of the definitions I found is this one, and it says the following: serverless computing, or more simply just serverless, is a cloud computing execution model in which the cloud provider runs the server and dynamically manages all the allocation of all machine resources. So, in other words, to simplify this a bit, we as developers use some kind of cloud service, and we don't actually care what resources and what infrastructure is needed for these resources, to operate as smoothly as possible. That's whole, the responsibility is completely on the cloud provider to do that. And one of the misconceptions that we often see when we are talking about serverless is that there are no servers, where, well, actually that's not true, and servers are not going to just magically disappear. There are always going to be servers, of course. That's not the point of serverless. As I said, the point is we as developers do not want to, we don't care about these servers, we just want to get our job done. So, if we could quickly just summarize what serverless is, maybe we could do it in these 4 key points. So number 1, as we've said, 0 servers to manage. Then the direct consequence of this is we don't have scaling issues. We know that this is a really hard work. Number 3, this enables us to build things faster. And number 4, here we have a little different pricing model. So, unlike the previous pricing models where we pay for services for like a minute or maybe an hour or for a month, depending on, of course, on the cloud provider and the service you are using, here we only pay for actually what we use. So, if we are talking, for example, about functions, here we only pay for execution, for each execution. So that's about it about serverless. We have a lot of stuff to go over, and I just wanted to end and say that there are lots of various articles, tutorials online. So if you are interested, I encourage you to check it out. It's really interesting stuff. And I'm just going to end with this sentence. So in essence, what serverless provides for us, it allows us to spend less time worrying about infrastructure and gives us more time on solving real business problems. All right, let's continue with one of the central terms of this presentation. So we're going to talk a bit about server-side rendering. And what is server-side rendering and why do we actually need that? Well, in order for me to explain that, I decided to take a step back and say a few words about single-page applications. So, if you are a web developer, I'm sure you heard about this concept. Well, basically, these are the main features of every single-page application. So, first and foremost, we have client-side rendering. So, what does that mean? It simply means that all of the interface and the HTML is being generated inside of the user's browser, right? So, the cool thing about that is that you don't have those full page refreshes. So on each click on a link, only the part of the user interface gets re-rendered, and that in general produces much better user experience. Then we have cleaner code. Usually you have two code bases. One code base that represents that single page application, the other code base that represents some kind of backend, and these two systems, are connected with something like an API URL. That's the usual way we would do it. And finally, single-page applications are easy to serve, especially if we are talking about serverless technology. So basically, we create a production build of our single-page application. We upload that to a static file storage of our choice, for example, Amazon's S3, and that's it. And if we want things to work even faster, then we can just place a CDN in front of the S3 storage, and basically we are immediately ready to serve our app to millions of users. That being said, of course, your single-page application will be fast as your backend. So if you have a slow backend, you cannot expect the SPA to work fast. I just wanted to know that. All right. These are some of the advantages of single-page application, but of course single-page applications have some disadvantages, and the main one is the one I'm about to explain in the following few slides. So normally when you create websites, web applications, you would expect to have these kind of link previews, right? So you share a link, for example, on social media, on Facebook, and once you share it, you would expect to receive this preview. We can see we have a page title, page description, and we have an image that represents that page. But if you have never worked with SPAs before, you might receive something like this. So I again shared the link, and I didn't receive anything. I only have the URL that basically doesn't mean anything. And why is that? You start, to debug the whole situation, and you very soon land on your index.html file, which is the same. It is served both to regular users or web crawlers. And where is the problem here? The problem is that this initial index.html that is served to everybody doesn't tell much to web crawlers, right? We only have a few generic HTML tags and, of course, links to the CSS and JS files. And this is a problem because web crawlers cannot work with this. Web crawlers simply work with the initial HTML that they receive. They cannot really, execute your single-page application and see what was rendered immediately, right? So this is the only thing that they can work with. And of course, social media isn't the only problem here. Even bigger problem is SEO, search engine optimization, right? And while there are, search engines are working towards solving this problem, and they are trying to support single-page applications every day, that support simply isn't at a level that we could say confidently we are, okay with a regular single-page application. We don't need to do anything else, right? So we still have to, implement some other approaches in order to solve this problem. And imagine yourself, you're working on a project, you have a super nice single-page application, and right 3 or 4 months in the project, when you're about to launch, you realize that your search engine optimization doesn't work at all, and even worse, you start Googling things and you realize that this problem is a big problem actually. It isn't easy to solve. But this is not a new problem, and there are solutions and approaches that you can use, to solve this. And the important thing to note is that each of these solutions and approaches includes some form of server-side rendering. What that means, it means that we won't be completely, relying on the single-page application. We also have to, shift some work to some kind of backend. When I say backend, it can be anything really. It can be a simple Nginx server, Node.js, functions, it doesn't matter. I simply mean that some HTML needs to be returned initially when something makes a request. So instead of returning something like this is what we've seen before. We must return something that's a little bit more complete, a little bit, more meaningful. And I don't know if you can see it, but basically we have a full HTML document with meta tags, links, and of course the full body of the page the user has visited. And this is something that search engines and in general web crawlers can work with. So how to implement this? How to achieve this kind of functionality? With this, we can take a look on the following document. It is basically a document that's talking about different rendering approaches on the web, and it is officially posted on Google's blog, so you can check it out if you have a chance. I encourage you. It's definitely an interesting, blog to check out. I'm not going to go, of course, into details about every approach. I'm just going to go, I'm just going to get you an overview to see what's out there. So at the right side, first we have a full client-side rendering approach. So what is this? This is basically what we've already seen. So when a user lands on your website, single-page application is initialized, and the HTML is rendered. And of course, the disadvantage of this approach is that there is no search engine optimization. But if you are building something that doesn't require SEO, for example, you're building a simple administration interface, you don't care about SEO, so this is also a valid approach. Next up, we have client-side rendering with pre-rendering. So if you've ever used Gatsby, you probably know how this works. So with this kind of approach, you reach at one point in time the build step, right? You have to build your application. But what is specific to build process, to this build process, is that all of the pages of your single-page application are generated in advance. So once the build has finished, you end up with a bunch of pages which you can then statically host anywhere you like. And this is great for SEO because all of the pages have necessary tags, the body and everything. And it's also super fast to serve. So because there isn't any dynamic generation, everything is just served statically as demanded, right? Only disadvantage of this approach is that you always have to build everything. So even if you are making a small change to your website, you still have to build all of the pages and ship everything to your host, right? So that's the only disadvantage. If you have a site that constantly changes, then this approach might not work for you. But if you are building something simple, something that changes very rarely, this is still a valid approach. Now we have this. This is server-side rendering with rehydration. Unlike the previous approach, where we pre-generated all of the pages in advance, here we generate the HTML as required. So we have a user who visits your site on some form of backend. We execute some kind of process, generate that HTML, and serve it back to the user. And what is interesting in this approach is that this process is only happening on the initial request or when user refreshes the page. Once the user receives that initial HTML, the single page application will actually boot up, initialize, and he will continue to use the site as the regular single-page application. So this is also called, if you ever heard about isomorphic apps, this is that basically. The only disadvantage of this approach is that you have to have 2 production builds. Why is that? So you have to create 2 builds of your single-page application. One build is served to the users and to their browsers, and other build is executed on the backend. And why is that? Simply because user's browser and your backend aren't the same environments. They are totally different environments, and often you have to make additional configurations to that code. So it can be sometimes it can be hard to set everything up, but once you get to the stable level, it's okay. You can work with that. All right. The final 2. Static server-side rendering and server rendering might not be super interesting to us, but it depends really what what do you need. Static server-side rendering also includes generating all of the pages in advance, but here I specifically remove all of the JS code from the pages. So if you don't rely on JS much, or if you don't need it, then this is still an okay approach. And finally, server rendering. This basically doesn't fall into the group of single-page applications at all. This is basically the exact opposite of the full client-side rendering we had in the beginning. So basically, every time a user clicks a link, we have a full page refresh. And to some of you, that may seem like an old approach, but some sites still use this approach. Like for example, Hacker News. It seems that it works for them. So why not? All right, so what to choose? That's the question, right? Well, it really depends on the app and the website you are building, and the specific conditions and requirements that are in front of you. And the best thing to do is to analyze your app and to see, what do you need, what works best, and stuff like that. That's what we did actually at Webiny when we were building that page builder app I mentioned at the beginning of this presentation. And basically, in the rest of this presentation, I'm going to show which approaches we tried, and of course how we implemented that in a serverless environment. And I just wanted to remind you that, as I said, we are currently working mainly with AWS, so implementation will be specific to AWS cloud. But I'm sure if you're working with other cloud providers, you should be able to achieve the same thing using similar services. All right. We had to do this for our page builder app, and this is how page builder works in a nutshell, very quickly. So we have our admin users who are using a simple administration interface. They can create or edit existing pages and of course publish them. And this is a simple full client-side rendering single page application. That's the first one we mentioned before. There's nothing wrong with that. And on the other side, we have regular users, who are consuming the pages we have created. And here at the time, we also had a full client-side rendering application. And basically how it worked, like every other single-page application. So user would hit your URL, SPA would get initialized. Once initialized, it would create a call to a GraphQL API. GraphQL API would respond with the page content, and that's it. So this is a full client-side rendering, and if you remember, we've said that these kind of apps are not suited for search engine optimization, and that's something we wanted to fix. So when we decided we want to tackle this problem, we needed to set some initial conditions we want to meet. We want to keep the modern SPA way of creating web apps and websites. Then pages must be served super fast, and of course search engine optimization must work. Only when we would resolve all of these issues, we would confidently say, okay, we're good with this, we can move on to some other tasks. All right, so back to the rendering on the web document. So what did we choose? Basically, first we had chosen the SSR with rehydration, simply because the other approaches weren't flexible enough for us. As we said, the full CSR doesn't have SEO support, so that's immediately discarded. And for example, CSR pre-rendering simply isn't flexible enough because you create pages in your build process, right? And we had an administration interface in which the user would publish pages, and these pages must be immediately available to the public. So this is the first approach we wanted to try, but before doing that, we also wanted to try something that isn't on this list, and that is pre-rendering on demand. So what is this? Well, we simply ask ourselves, what if we could distinguish between users and regular users and web crawlers? And to regular users, we would just serve the regular SPA we already did. In reality, users don't care which HTML initially they got, right? And on the other side, when we have web crawlers, why don't we, serve them the same HTML the users would get when they would, open your SPA and everything was initialized. So the same HTML that user would get, we would also serve to web crawlers, right? So this is also the approach we first wanted to try, and in the following slides I will show you how we have implemented these. So we wanted, of course, implement everything in a serverless environment, and we knew a couple of things at that time. We knew that we wanted to use functions instead of servers. So basically, functions are basic building blocks in a serverless world, and the good thing about the functions, they scale automatically. So you don't have to, worry about scaling or anything, or security or patching, maintaining, anything like that. And the only thing you can configure with these functions is the amount of RAM that you allocate to them. So the more RAM you allocate to these functions, the better performance you can expect from it, right? But of course, the more RAM you allocate, it also gets more pricey, so you have to think about that. Next up, we knew that functions can not only serve as an API endpoint. Usually when you look over various tutorials online, you will see the most common use case for function is to build API endpoints. For example, one function that handles get users, the other function that handles update users, and so on. But this is not the only use case. You can pretty much use functions for anything you like. And you can use them to serve HTML, and you can even use them to serve binary files like images, sound files, and so on. So that's definitely a good thing to know. And the only thing, at least in the AWS cloud, that you need to know is that you can respond with maximum of 6 megabytes in size. So, but that wasn't a really concern for us because we certainly aren't going to, to serve 6 megabytes of JavaScript or something like that. And finally, there's this thing called cold starts. If you have been playing with functions, I'm sure you heard about this. But basically, what happens here, when you invoke a function, you have to go through the initialization process. This happens only once. So what happens in the background, a container is spun up in which the function will be executed. And this is a process that takes time. In some situations, it can take from 200 milliseconds, 400 milliseconds. It really depends on the code you are shipping and the amount of allocated RAM. In some cases, it can even take up to 1 to 2 seconds, and we have also seen extreme cases in which this can take to 10 seconds. This is a rare case, but it can happen. We've had experience with that too. So this is something that you have to have on your mind. If you're building something, that is it must be super fast. You have to account for these cold starts that they will happen. All right. So with that being said, let's finally jump into the implementation part. Let's first take a look on how we implemented the pre-rendering on demand. So for this, we actually used a few of AWS services. We used S3 Bucket, to which we uploaded our SPA production build. And we used a couple of Lambda functions with that. And to put all this to the internet and add some caching capabilities, we also added API Gateway and CDN. And with that, we also use this cool little library called Chrome AWS Lambda. So what is that? Well, as it says, it's a Chromium binary for AWS Lambda. In other words, imagine you have a browser, and you can programmatically control inside of your function. Basically, you can, point it to a URL and wait for the HTML to be generated. Once it's done, you take that HTML and you do with it whatever you want. And in our case, we wanted to take that HTML and to serve it to web crawlers. So this is the tool we used for that. And how it all works, this is a diagram that shows that. So as we said, we have two scenarios. In the first scenario, we have regular users. And in the second scenario, we have web crawlers. And this is the first scenario. So when a user visits the website, the HTTP request is first handled by the CDN, and it is forwarded to the API gateway. And finally, the API gateway knows that it needs to invoke this server lambda function. And what happens there? You notice that we call this here. We call this function server lambda. Why is that? Well, simply because this lambda function acts in a way like a regular web server. It receives a request and responds back with a file. It pulls a file from the S3 bucket you can see below. And the only additional thing that this lambda function does is that detection I've been talking about. So in this lambda we detect if the request has came from a regular web user or a web crawler. So in this case it detected successfully request has came from a user, pulled the file from the S3 bucket and should respond back via API gateway and CDN back to the user. And in the second scenario, when a web crawler visits your site, basically the beginning is the same. So again, HTTP request reaches server lambda over these two components. And what happens then? Server lambda basically just forwards that request to upper lambda, that's called pre-render lambda. And this is the lambda function that actually includes that Chrome AWS lambda library we talked before. So basically, the request is forwarded up, and Chromium is pointed to the URL which it received. Once the whole HTML has been generated, it will respond back. Server lambda will receive that HTML, and of course the HTML will be served back to the web crawler. A couple of things just to note here. So in this second scenario, the S3 bucket is never touched. The S3 bucket only serves when regular users visit the site to pull the file out of the bucket. And the other thing to note here is that you may be asking yourself, why didn't we put everything in a single function, right? Well, this is simply because the library, Chrome AWS Lambda, the Chromium binary, actually requires a lot of system resources to operate. And if you check out their official documentation, you will see they suggest that you go with minimum of 1600 megabytes of RAM. So this is a pretty significant amount of RAM. So when a regular user visits your site, we don't need that much of power, right? We just want to serve a regular file. And a Lambda function with minimum amount of RAM will do the job just fine. So only when a web crawler reaches your site, only then we trigger this pre-render Lambda with lots of RAM. And of course, the point of that is to save us money along the way. All right. So these are a couple of tips. The only tip I would like to point out here is regarding the Chrome AWS Lambda. So there is a trick there. You can configure it in a way you tell it that it don't download CSS and images, right? So when Chromium is opening a URL, it doesn't have to download these assets because these assets doesn't produce any DOM. So no matter if you download CSS or images, the resulting HTML will always be the same. So no need for download these files. Finally, some pros and cons of this approach. Well, the main pro is a simple architecture. We've seen that with a couple of AWS services we've been able to achieve this. And more importantly, in this approach you don't have to have two different production SPA bundles, builds, right? Like we have in SSR with rehydration. So only one bundle is here required, and that's it. But more importantly, what we had issues with is the speed of the page load. So page load times weren't good enough. And you know, when you open a single page applications, normally what would you see? You would see a loading screen first, right? And that would take, for example, a second or two or three, and that is something we didn't, you know, consider as acceptable. So because of this user experience issue, in the end, yeah, we tried a couple of things, you know, to try to optimize this, but in the end we couldn't manage to get a reasonable user experience. So because of this, we actually decided to discard this idea. So just wanted to, you know, to point out that in this case we didn't have a problem with serverless. We had a problem with single page application, with the way how they work. And in the end, I just wanted to say that if this initial loading screen isn't a problem for you, if you only care about SEO, then this is still a valid approach. You would be able to use it. All right, the second approach we tried is the server-side rendering with rehydration. How that looks? Well, basically, for this one, we even used less resources. We used a couple of Lambda functions and the same as before, API gateway and CDN. And for both users and crawlers, the flow looks the same. So every time the HTTP request has landed, it will eventually reach the server Lambda. And what this server Lambda will do, it will just call the upper server-side Lambda. And this server-side Lambda that you see above is actually the function that holds that production build of our SPA. So that Lambda is actually responsible for generating the HTML that is going to be served to users and web crawlers. So, of course, again, there are pros and cons of this approach. This is the funny thing. So, although we managed to, you know, to resolve the SEO problem we initially had with both approaches will work. It's interesting that with both approaches, basically we had page load speed issues, right? So what we had here, if you remember in the previous approach, users would receive a simple single page application and they would have that initial loading screen, right? With this, the situation is pretty similar because we have the same process happening on the backend now in that SSR function we've seen previously. So now we've actually made the user experience even worse because now when the user opens your URL, he just sees a blank screen. He doesn't see anything. At least before he would see a loading screen, right? Now he only sees a plain white screen. And as I said, this is because the same process the user previously had in a browser now is happening on the backend. And the bottleneck is actually now there. And again, we have we are dealing with this problem. And when you're having speed issues, normally you tend to implement some kind of caching mechanisms, right? So we tried two different variations of caching, and the first one basically looks like this. So on every request that we receive, we would call the SSR Lambda that we can see above. And once the server Lambda function receives the HTML, it would cache it in memory, just in memory, nothing sophisticated here. So that means the next time this user again or another user visits your website, this SSR HTML wouldn't have to be regenerated. You know, we would be able just to use the cached version of that HTML and just return that instead. And we would cache it for like 30 seconds. You can experiment with that. You can put 60 seconds or so. It really depends. And the cool thing about this is that you can also cache that HTML on the CDN edges. So if a user visits your site, the SSR HTML will be served actually from the CDN. And if that happens, you have a really fast website. Is loaded in 100 milliseconds or so. So really fast. But again, what happens when the cache expires, right? So again, user would visit your website, and again the same thing happens. He would again have to trigger the upper SSR Lambda function, and again we have a slow site. So what's the point of this, right? We would cover, some percentage of visits, but other percentage of visits would still be slow. So we needed to upgrade this, and this is where variation number 2 comes in place. So what we did, we again have the same diagram as before, only this time we added the database in the mix, as you can see on the right. So what happens now, basically when a user requests a page, Server Lambda will, of course, trigger the upper SSR Lambda, but this time it won't directly respond back. This time it will take that HTML and save it to the database, right? And what that means, and of course when it says that to the database, the HTML will be served back to the user or the initial requester, right? And again we have the same pattern repeating, but this time when the cache expires, we are doing the following. Server Lambda will always check the cache. If the cache has expired in the database, right? If the cache has expired, we would serve that stale cache to the user. So the user wouldn't experience that generation of server-side rendering HTML. They would receive an old cache, right? And while doing that, we would also asynchronously trigger a regeneration of already existing cache. So that means the user that visited the website, he would receive an old HTML, right? But the next user that visits the website, he would receive a new HTML because asynchronous regeneration has finished and it's ready to be served again. And this is the process basically that is continuing, it's repeating all the time. So for this approach, the great thing about this approach is that user never experiences that SSR HTML generation. And when he visits the site, if he hits the cache, he will view the page in 100 milliseconds or less. And if he doesn't hit the cache, he will receive that stale cache, and that's like 200 to 400 milliseconds, and that's really okay. We consider that as a good timing. And this is it, pretty much. So the final solution we implemented for our case, for our page builder, is server-side rendering with rehydration and also with appropriate caching mechanisms in place. Just wanted to mention that you can still use the previous approach, pre-rendering on demand. As I said, if you're okay with loading screens, that's still okay approach. And yeah, use what works best for your use case. And by the way, if you're using Webiny, you get this out of the box, so you don't have to torture yourself with this stuff. Thank you. This is pretty much it. I hope I managed to, transfer some of our experiences to you. And for the end, I just wanted to say that we are hiring. So if you're interested in this stuff, send us your resume at jobs@webiny.com. Thanks.
Thank you. Does anyone have any questions, perhaps? None?
No question.
So I have a question about the difference between the web crawler, what you hand to the web crawler, and what you hand to the user visitor of the web page. So can you clarify a little bit what is the difference? Maybe I kind of...
yeah, there is no difference actually. We only detect if a user has visited the website or a web crawler, right?
All right.
And if a web crawler has visited the website, we use that Chromium browser in a function, and we point it to the same URL the user has requested. And in that browser, we tell it to wait for the whole SPA to, to generate the whole user interface, HTML and all that. Once it's done, we take that HTML and simply serve that to the web crawler. So basically it's the same thing that the user would see once his SPA has fully initialized.
All right.
Yes?
Why not create that cache on edit? So when someone edits something in administration, why don't asynchronously create that cache then instead of waiting for requests?
Yeah, we're doing that. Great question. Yeah, basically we are currently also working on this problem. We have discovered some new things along the way, which I couldn't prepare for today, but yeah, of course, we actually do that. So each time a user creates a page, I decide to publish it, we asynchronously trigger that so the user doesn't experience that delay. Yeah, great question.
You should send.
Send, yeah. Great.
Does anyone have any questions? Oh, no? Okay. That's it.
Cool, thank you.